This is 1.5, rewriting equations and formulas. We have something called a literal equation, and that is an equation that has two or more variables. And a formula is a type of literal equation. So to rewrite a literal equation, we're going to solve for one variable in terms of the other. That means we're going to get one variable all by itself and put everything else on the other side. So if we are going to solve for y, we have 8x plus 2y equals 18. To put my x on the other side to get y by itself, subtract 8x, then I'm going to divide everything by 2 to get y completely by itself, and y equals 9 minus 4x. Here for 2 times 3x plus y equals 20, I'm going to distribute that 2 to get 6x plus 2y equals 20, then move my x to the other side to get y by itself, and then divide everything by 2 to get y equals 10 minus 3x. I don't really care what this other side looks like, as long as it's simplified as much as I can, and my variable that I'm solving for is by itself. Now if I solve a equals 1/2 base times height, we're going to solve for b. To do that, 1/2 and h are each being multiplied by b. So I divide each side by h, then I need to divide by 1/2 by multiplying by the reciprocal, and I get 2a over h equals b. And we solve 3 plus 5y minus zx equals y. Here I have 3 different variables, but I'm solving for x. And I only have one x. I can do that. So let's move the y's to the other side. And then I'm going to move my constant to the other side. Then I have negative zx equals negative 4 times y minus 3. This z and x are being multiplied, so I need to divide by negative z to get x all by itself. And I get x equals 4y plus 3 over z. And some equations have no solutions. Some equations have infinitely many solutions. We have something called an identity, and that is where an equation that is true for all values of the variable, where 5x equals 5x. X can be any real number, and these will always be equal. So when each side is the same, that is an identity. So if we have 7 times 3x plus 2 equals 21x, if I'm solving for x, I distribute, then put all variables on the same side, and I get 14 equals 0. 14 does not equal 0. That is not true, so my answer is no solution. Now for 3 times 4y minus 3 equals 12y minus 9, if I distribute, then I move all variables to the same side. I don't even have to do that because I can recognize that 12y minus 9 equals 12y minus 9. Each side is exactly the same. That is an identity, and we have infinite solution because that is always true. It does not matter what my variable is. Here's a couple common formulas for you. We have temperature, where C is in Celsius and F is in Fahrenheit. We have simple interest, where I is the interest, P is the principal, that's how much you started with, R is the annual interest rate, put that in a decimal, and T is the time in years. If you are not given years, convert it to years. And then we have the distance formula, where D equals RT. R and T are being multiplied. D is distance, R is rate, and T is time. The time needs to be the same unit as the rate. And if we do this one, person A ran 3 miles in 35 minutes. Person B ran 5 miles in 52 minutes. Who ran faster and by how much? So I'm going to use the distance formula, and I'm going to need to solve for R at some point. For person A, I know their distance and time, so that is 3 miles, and their time was 35 minutes. To get R by itself, divide each side by 35, and I get they went 0.085 miles per minute. For person B, I have 5 miles equals their rate times 52 minutes, and their rate is 5 over 52, which equals 0.09. Now, I know that person B ran faster because 0.096 or 09 is greater than 0.085. So they ran faster by 0.011 miles per minute. That is not much faster, but it is faster. If they were racing, person B would have won.